In this video, we're going to continue our discussion of survival analysis, and we're going to take a look at an overview or a schematic of what a survival analysis looks like, as well as touching on two of the key issues underlying the performance of a survival analysis. And the first issue to make note of is that a research participant, a particular case, does not experience the key event during the period of data collection. So if you have a 3-year period over which you plan to run the study and you enter somebody in at the very start of your study or 2 years into the study, there is that possibility that a person just does not develop that particular event or does not experience that event. So in this case, there's no observation in time. And really what we're looking at in this situation with this issue is we're going to observe the lower time boundary. And to illustrate this, I'm going to use an example of observing time to retirement. And in this particular case, the retirement is the actual key event. So in a study like this, there are a number of predictors that a researcher can focus on. They might focus on the salary level of the employee, their health status, their age, the money they put aside. All these are potential reasons that a person would use to contemplate retirement, but you can apply this in a survival analysis, taking a survival analysis approach. And so imagine that you're carrying out this study and you set to carry out your study over a 5-year period. And during that 5-year period, as a researcher, you're going to enter in employees that have not yet retired. Now, in this particular scenario, let's imagine that your data collection period ends. So if you've identified a 3-year window or a 5-year window, at the 3-year or 5-year point, depending on how long you set up your study, the study comes to an end. And you find that you have a 68-year-old at the closure of the study that's still working. They have not yet retired. So the event for this particular person has not yet happened. And so in that situation, this 68 years becomes what's called the lower boundary. But because this person continues to work past the closure period of the study, we would say that this person's data with respect to the event is censored. In other words, as we move from left to right in time, the event has not happened for this person. So we would say that these data are right censored. And it's important to note that this is specific to a single person or a case or a participant patient. And in this schematic, we're going to take a look at how a survival analysis plays out with respect to the study timeline. And so in terms of the study timeline, you see that in this example here on the x-axis, we might be investigating the time to death for high-risk patients. And there are a number of different scenarios that are referred to as different types. And we'll take a look at those right now. Starting at the top, we see that this red arrow illustrates what's called a right censored case. So this would represent a patient entered into the study. They're alive prior to and at the point, so here we see January 1st, 2020, and this person enters the study, and they continue through the follow-up. And after the end of the study, January 1st, 2022, so this is a 2-year study, the event has not happened for this person. So the time to death has not happened as they continue past the study. That is what we would call right censored. The event isn't happening here, and so we would say on the right-hand side it's censored. For many cases, we see type B, where this is a participant or a patient enters a study at the start and they do not survive through the end of the study. So in this particular case, in type B, it's not censored at all, but complete information is available for this particular case. In type C, here we have a patient entered at some point almost halfway through the year. This might be the month of April or May after the start of the study, January 1st, 2020. And so the person continues and the event has not happened for this particular person. So the entry was delayed for this patient, and because they continue past that point, we would say it's right censored. So we don't have the data on the right-hand side with respect to the event, but the duration is truncated on the left-hand side. So we don't have the full participation from the start of the study. Now, the entry of the different cases into a survival analysis is a research item, not necessarily one that's strategic. And so, because survival analysis is often carried out on very unique cases with patients and different conditions or diseases, as researchers identify those patients, they're entered in at various points of the study. So moving down, another situation here. Here we have type D, another case, which is left truncated. So we don't have the full data from the start of the study. The person entered the study as the person entered in type C, maybe in April or May of the year. The entry was delayed, but it's not right censored as type C was. So type C entered late. The event did not happen after the end of the study data collection period. But in the type D case, the left truncated, the event did happen for this person. And so these are data that would be retained and analyzed in a survival analysis. In this case here, this is another unique situation here, type E, which is certainly left truncated, but the data are not included here. So researchers may have identified a patient for potential entry into the study prior to the official launch of the study, but the event happened prior to the official start of the study. So that highlights the important item here with survival analysis, that the period at which the data entry started has to be identified by the researchers. So there's a definitive start point and a definitive end point. So during the period of subject, participant, patient recruitment, the event happened, but these data would not be included. After the study ends, oftentimes a patient or a case has been identified. And so here we would say this is right truncated, and entry after the study ended, these data would not be included. So if this represents a patient that undergoes the treatment that was studied in this study, but because this patient was identified and entered into the treatment after the official closure of the study, these data would not be included. These would just simply be referred to as right truncated. So the second issue here with survival analysis to be aware of, and this could present some complicating factors, but the complicating factor can actually be accounted for in the study, has to do with the predictor variables. And so on slide number 5, we didn't identify a predictor variable. We were just examining the timeline for event identification. So in terms of the second issue here related to predictor variables, some predictor variables do change over time. The example, using an example here, if we are examining the time of to reoffend following the release from incarceration. So we have somebody who's been incarcerated for some crime, they achieve parole or a full release, and our interest here is the time to reoffend. The reoffending is the actual event in question. So in this particular type of study, researchers might be interested in whether the employment status of the individual would have an effect on the time to reoffend. And so this particular predictor variable is dichotomous in nature, where we just simply say, yes, the person is employed, or no, the person is not employed. However, as to be as concerned with as a concern with dichotomous variables, this is stated far too generally and doesn't encompass the full nature of employment status. And so researchers may want to ask the question, what about the type of employment? Is it part-time employment? Is it full-time? Is there overtime work? Does the person change their employment status during the period of the study? And that's something that would certainly impact the time to reoffend, and that would have to be worked into the study as part of the predictor variable. If we just leave it as a dichotomous variable, these very important items here would not be accounted for in determining whether employment status is beneficial for somebody released from incarceration. In this particular scenario, in the fourth bullet item here, this type of predictor would be called a time-dependent covariate. So the time to employment and or the type of employment is an important issue to investigate the key outcome here, which is the time to reoffend. So what we see here in terms of predictor variables, some do certainly change over time. Researchers need to be aware of this in terms of setting up how they wish to examine their predictor variable. So this ends our second video here on survival analysis.